Okay, so two handouts today that are summaries of previous lectures. I got to start by correcting a typo in the first one. I'm going to get this name right before the end of the class. Can we have this on Mary Claire? We got her first name spelled right, but now her last name has a lowercase v instead of an uppercase v. Now, I guess her book still hasn't come into the bookstore, but since it's from Random House, it ought to be coming in soon. But I think there's a rumor that both Stacy's and Printers Inc. do have copies. And so if you, instead of going to the Stanford bookstore, there's other bookstores around that would probably have it. But a little bit more waiting should do also. Now, Mary Claire has told me a wonderful thing. She will help read your term papers and the drafts of your term papers to give you feedback. So we're going to have a real expert pitching in on the grading for this course. Okay, now let's see. Anything else? Old business. I wanted to talk today about some experiences on what I call literate programming and show you some of the ways in which people are groping with finding a style when you're using a new form of expression. And I think this is kind of interesting to see the evolution that goes on. I know it certainly happened in my own case. I spent about, as I was designing the web system, I spent well, let's see. The first test case was to write web in its own language, and so I started out and I wrote about 25 pages of code in what I thought web would look like. Then I tore it all up and started over again. But by that time I had developed a style that seemed to be working, and then and of course then I have to implement the program that's translating the text I'm writing. So there's a vicious circle there. You have to have the program before you can do it. Now, after I had the program written, by the way, I had to bootstrap it. I had to first simulate by hand the computer program that would take my web program into Pascal by making a Pascal program by hand from my web specifications, and then I had to debug that, but I didn't have to have the whole Pascal program. I could leave out the parts that were generating error messages or something that I wasn't going to be using when web runs correctly, it doesn't generate errors, and so I only had to implement a subset. But you start out, and in order, it's a little bit interesting, computer science, to figure out how you get web going on a new system. If you have a Pascal compiler and a TeX processor, you should be able to. But let's suppose you only have a Pascal compiler and you want to, and somebody sends you some web files. So this means you have a copy of Weave Web and Tangle Web, the two processors, the Weave processor and the Tangle processor, written in web. But all you have is Pascal. So you also get a copy of Tangle.Pascal, the output of Tangle on itself. And once you've got that, then you're in business, because you can then use that to tangle with a few changes for your own system, and you can use that to tangle Weave, and then you can get going. But the bootstrapping process is like all bootstrapping processes. You start out with a forced, limited amount of capabilities that gradually build on themselves. It's like when you boot a machine. when a machine makes a cold start, the hardware knows how to do almost nothing at first, and then it gets more and more of its stuff in, and so on. Same way with that. Well, that's a minor point. Now, so I was bootstrapping. However, in another sense, where I was actually trying to design a system for literate programming, and so I had to evolve a style of how I was going to write the program and so on, and then after I had the web system, I could start writing tech. The whole process of writing the web system, though, was about 2 months. 2 months of programming. It wasn't a great slowdown, and then several years to get tech all refined because tech was supposed to be a permanent product, while web is was just an experiment. And there's many things in web that show the fact that it was only done in 2 months, and it was never intended to be a permanent thing, just as a demonstration of what could be done. But I think that now the experiment has been so successful that it's been demonstrated that programming environments based on some kind of a system like this are called for, and that's what the current research is doing. Well, what I want to show you is how the undergrads that I worked with last spring adapted to this style of programming, and some of the painful changes that must go on when you have one way of writing programs, and then someone tells you, now I want you to write a different way. And some of them did it rather reluctantly. Some of them did it took to it real fast. It's hard for me as the author of the system to look at it, of course, in a dispassionate way. I get various kind of feedback. Some of it's very pleasing because I've heard of some people said at Hewlett Packard in their division they started using this way of coding, and the guy said he would never leave Hewlett Packard unless it was for another company that was using web. I mean, he thought it was the right way to program too. So, well, now let me show you first, though, an example of one of the students who probably didn't like it very much. So now each of these programs I'm showing you is for a slightly different problem, and the idea is that the students are writing programs that I'm going to eventually rewrite as part of a larger project. But I wanted to get their input and ideas on how to do it. Okay, this particular program is based on 5-letter words of English. Can you zoom up on it a bit more? I want to go actually to the top here. I would like to get this in pretty, this up here. Yeah, pretty close up on this guy. Then I can pan it for there. Now, 5-letter words is one of the things in this we're working with in this particular project. We were taking I have a database where I think I have all of the 5-letter words of English, and I wanted to check that I really did have them. So I was going to have this guy go through all the computer files that we have of text, especially text that I've written, and look for the 5-letter words that appear in there and see how many of those 5-letter words were not in my database. So anyway, that's the idea of the program. And he starts out, and first of all, at the beginning, the first paragraph just suffers from ordinary ideas about English writing. This program reads a list of 5-letter words and puts them into a dictionary. It then scans an input file of text and finds the 5-letter words. I changed it to then it scans an input file of text and finds the 5 hyphen-letter words, because he hyphenated 5-letter words in the previous sentence. He should hyphenate 5-letter words and all that. So standard ideas of English go in here, and then there's a problem about the it not being. It checks to see if the word is in the dictionary or if it has already been found by the program, and so. That it wasn't too clear. So if the word is in the dictionary or if the word has already been found by the program. Then it says if it isn't in either list. So I said a word that isn't in either list is added to the list of words found, and all this. Now, okay, so at the beginning, introductory paragraph, just ordinary writing there. Now, then we got to the begin to actually start using web and all this, and so he has something where he's called size of word with caps. I said here I made that symbol, which means go to lowercase. But I now see I misunderstood him. He's talking about probably a string called word, which is defined down here. And so what I should have told him to do here was really put vertical lines in his file, which would mean that then typographically this would mean the variable, the program variable word, which would then go into italics. Now as I told you the other day, the idea of web is that you stick in one module for another. Like here, you see this types goes in, and variables, and the main program gets stuck in, and then you describe those separately in a part where it's convenient for exposition. The person was still writing a Pascal program and still thinking of it as a Pascal program and not getting the idea of how to present a program in this form. And so really there's very little difference in this exposition other than an ordinary one. So he starts out and he finds types, and then he says these are the global variables. Now let me explain about the advantage of not doing it this way, which of course then he understood on his next draft. I guess the best way to show you is to show you the example of this. This is the largest program that I've done with this style, and it's how many parts altogether? Let's see. What is it? 1,376 parts to it, and I believe that there are now hundreds of people in the world who have gone through this rather thoroughly and understand this program quite well, and it's a long program, but still it's possible to present even this and even for short programs the same kind of thing happens. But in this case, there's something I call global variables. But if you go to module 13, it's not going to be a list of all the global variables in the program. Instead, you can keep introducing global variables anywhere you feel like another global variable. And so let's look at section 20, for example. Section 20 is where I get some global variables. Now, this is a feature of web I didn't talk about on Monday, and that is that you can have many different sections with the same name. So section 20 has got this name. The Pascal code in section 20 is global variables. The Pascal code in section 13 was global variables. And the first, and they all get collected into the program in one place, but you keep on adding to this part of the program every time you have another global variable you want. You introduce a new global variable. And so when the person reading your program is psychologically ready to know that another variable is going to be put in there, then you tell them, okay, by the way, here's a global variable that we're going to put in, and that's one of the features of the web tangle system, that this will get concatenated. It will be added on to all the other things that were mentioned as called global variables. So you can, in other words, there's a question of motivation there, and the whole idea is to try to present a program in a form that a reader is ready to pick up the idea of that part of the program. This is quite different from the form that you present to a Pascal compiler. First you tell the Pascal compiler you list all your global variables, but the Pascal compiler, you don't have to motivate the Pascal compiler. It'll do this. It's just not getting. In fact, the psychology of computer programs is a little bit interesting, because everybody thinks that when they get to the parts of their program that were hardest to write, the machine slows down a little bit when it gets there, because it's hard to understand what it's doing. But no. But in fact, when you look at the running time statistics, most of the time the machines are doing things that you didn't spend much time writing, and it's just. But you have we have a false conception of where our computer programs are spending their are working, and we think almost always that that the computer is 90% of the time working on the part that was hardest for us to write, but really 90% of the time it's passing over blank spaces in a comment or something like this that was trivial we never even thought about. Anyway, the psychology of it for a reader is what we're trying to do when we present the program, and it turns out that this is almost always about the same way in which you, when you wrote the program, had to make the decisions. About the time when you were writing the program and decided to have a global variable named something is about the time that somebody reading the program is going to want to know that there should be this global variable or whatever other decision you're making about a data structure or so on. So this stream of consciousness order of presentation of how to present the program to a reader, that the reader can understand what the program does, is rather close, I believe, to the order in which you actually made those decisions yourself as you were writing the program. And I find that as I was writing this long, 1,400 module program, it was always fairly clear to me that I had to do that I had to go in a certain order, that a certain module had to be the next one to do. I didn't have very much choice in my own mind as to what to do next, even though it goes on and on for 500 and some pages. I knew that I wanted to do first the printing routine, and then the routine that would print out error messages, and then a routines for data structures. Somehow that order was forced on me. It was just the natural question to ask myself, how am I going to do this as I write the program? And a reader who wants to read and understand the program, it's also the thing that the reader wants to know next. Very, very close, I think, in most cases. But here's an example where web isn't being used. It's just being used as a formatter for making somewhat better comments. But the order of presentation hasn't been caught here. You see also here's two right braces on separate lines here, indicating that he's used to putting comments on two lines, and forgets that a formatter might be able to get that all on one line, or choose the best line break. Okay, now let's see. So I'm starting out with showing you the learner's experiences with this, and minor problem here is put a hyphen at the end of a line, and the word processor thought that always put the space after that too. But let's see, what I wanted to mention, I guess, is problem of expositionness in general for how do you describe a computer behavior of a computer program. Are we running is the program off there running itself, some automaton doing the thing, or are we part of the action? Are we participating in the program somehow? That's livelier to put us in the picture. So probably we get so here you see if we have already found this word in this file, and it says if we have not, it puts the word into the list. Okay. Now it was a dilemma in his mind which way it was going to be, but I think you go with we on this. When you're part of the program, I think we're participating. So it's not only a dialogue, author and reader as a team here, but really we're also collaborating with we're also carrying out the algorithm as we're doing it, I think. And so see if we have already found this word in the file. So I rewrote it saying, if not, we put the word into the list of new words found. Okay, and then we say we keep finding 5-letter words and checking them until the end of the file is reached. Okay, so now another thing, in this style of programming, one of the main ideas of it, I guess the main idea was to understand a complicated thing locally by understanding each part and then how those parts relate to each other. And one of the keys then is to put a name into each part. So here we have a name of the main program, and then that invokes other parts, one called puts the word into the dictionary, and here was one called store the new word in the list of new words. Now, you know, we should try to think of a style that's consistent here. Puts the word into the dictionary is a what's the proper technical word for this? It's a description or something that puts the word in the dictionary. But here we have a definite imperative. Store, you know, it starts out with a verb saying do it. And I think that tends to work out best. Say put the words into the dictionary. So I would start out with an imperative, and it seemed to be best for me to capitalize it in that case, like the main program. Now, the main program was not an imperative. It was declarative, and there's different parts of the code that are imperative and declarative. For example, global variables, that's declarative. You're declaring a global variables. But when you so if you want to be imperative, you'd say do the main program. But the main program is really a piece of text. It's a declarative thing. Something is there. But when you start out with an imperative verb, you're saying this is a bunch of commands that are being executed. So I think it's a good idea to have that convention that you start out with an imperative verb when the module in question is commands. Start out with something, you know, the main program, something just plain old declarative. Just give a noun. When really the module consists of a piece of text that sort of has a declarative function, although the main program then the text actually is actions. There's a way to have what about long identifiers? Now he's got things called out file, in file, get word, find in dic, find in new words, and a lot of times people will use a convention in their text files. Now, when you have a long compound identifier made up of several words, to capitalize each word afterwards so that you get in, so that you can see where they break up. Well, this one, of course, was a little inconsistent there. This find in would have put an I in there. Personally, I find that looks bad typographically. These fonts of type that have evolved over many years were never intended for an uppercase letter to be following a lowercase letter, and they don't usually look very good in that way. It's not too bad on a typewriter and a terminal. So anyway, the web system has a way to make compound words that looks better typographically, I believe, and we'll see a lot more examples of it, where you would actually say get word with a little line in between, tying the two together. Now, Pascal doesn't allow this little line as part of the name of an identifier, but Tangle takes it out, and but it's still, you can put it there in your input file, and it tends to make the program look better, I think, a lot better when you have a compound name. And I think you do need compound names. It's impossible to find one word always that will describe everything in a long program. In fact, some people, I think this was an innovation of the Digitech. The people, it's called Digitech Corporation, who made a lot of waves in the early '60s by having the best compilers on the market. And their style of programming was to have identifiers that were about 40 characters long, but each one was sort of a short story telling you exactly what all the invariants and everything were encoded in that identifier. And I don't know how they got the typists to type all these things over and over again, but it was very clear reading the code what the meaning of every variable was. That was an extreme, but and then they didn't write any comments in their code at all. Okay, so that's this. Now let's see. So I would have called this word underline list as a better choice of name, I think. Okay, now, but evidently the capitalization means nothing to this person, because here's a CH and a CH, both caps, and he must mean the same one. Now the comment that I gave him at this one, this module is completely unmotivated at this place. Also, it's misnamed as it merely skips over blanks. So all of a sudden in the middle of this, after presenting two things here, which was fairly good. I mean, storing a new word, storing an old word. This was fairly reasonable parallelism, except there was no period there. But anyway, it was parallelism. But then all of a sudden we have a new something which is called skip to the beginning of the next word. And if you look at the code, it says it skips over blanks. Now we're reading an arbitrary text file, and the words in this text file are going to be, this is going to be a technical concept. Word means something that is preceded by a non-letter and followed by a non-letter or something like that. I mean, a word doesn't have to, there's, besides spaces, there's punctuation marks, parentheses, and all kinds of things in a file that aren't part of a word. And so when you say, if you would say skip to the beginning of the next word, you're talking about a technical thing, a word, a five-letter word that you're looking for in the file, and you would then skip over more than just blanks. But this is something that just skips over blanks, and it also has another problem with Pascal, that it assumes things that some Pascal compilers will do differently than others for writing portable code, but that's another subject. So there's no point in putting this module here until we're ready for it. So, okay. Well, now let's see. This was an example of engineerese. This module read a word from the word file and stores it in the dictionary. It does absolutely no error checking and assumes each word is all lowercase. No punctuation there and everything. That was just glitchy English. But then it was okay. And the comment in the next part here was, this module zips through the hash table, printing out all the words in each bucket. That made sense in the context of the thing. Well, now finally we get to the part of the program where it says finding the next five-letter word, and this is where I was expecting I would find the formal definition, stated informally, of what is a word. When we talk about five-letter words in this program, the whole point of this program, there should be some part of the text which says what it is. But no, that was all left to you had to read it from the code to smoke out what the idea is of a quote word unquote. So the main part of the documentation was missing here. Instead, his idea of what documentation should be is to give a play-by-play account, saying, so here it is. You see, it's like it finds the next five-letter word. If it reaches the end before it finds the five-letter word, it returns the Boolean value false. It first checks if it's at the end of a line. If so, it does such and such. If not, it does this, reads it, converts. If it is a letter, it does this. If it is not, and so on. It exits this loop while it so this is a transcription of an algorithm into words, but it would be better to give the intuition. It would be better to give a high level rather than a play-by-play in this part, to set the scene for it. The play-by-play can be, anybody can understand the ifs and much easier reading code than by reading a whole bunch of ifs, thens, and things like that. What you want here is the feeling for what's going on, I think. misconception. Now here's another thing about this module is too long. You haven't discovered why web is good yet. Okay, so here we have a whole page of code, and that's it. Now the idea in web is to break a complex thing down into small parts, and ideally about a maximum of a dozen lines of code in every part. This whole box in here, for example, I would call a new module. I would call read from the file until coming to the end or to a word of the correct size, say something like that. And then that would be you could read then this function get word, and you would be able to understand the function get word as a unit. Then if you want to find out exactly what it does when it's reading from the file, then we go into this other module, read from the file, and we get to see it in place. Now, but here's a strange thing, and I still don't know what happened, but I say, oh my, you've really broken weave. This is all formatted wrong. I have never seen my program do this before, and so somehow he must have inserted line breaks in his program or something that would cause the then to be on a separate line from the if, and the begins aren't lining up right. Everything is broken, and I have no idea. I've never seen this happen before, and the only way you can do that is by putting little hidden commands inside and saying do something unusual, and so anyway, so that's all broken there. That was one. So I was a bit discouraged when I saw that first one, but things got better. Another student here. This brings up some more points about the use of a new system. One of the special things is that there's a module can be given a title that's going to carry over for several other modules, and then that becomes a subhead at the top, like the program or something. Use it here. But the very first module, the student didn't use it, could have said introduction or something like that. So instead, we just got a sort of a default subhead at the top. So I just suggest write that. But now here's something more interesting. I think he says, given a file name xxxxx.yyy, it will create a reverse file xxxxx.rev. And these are all caps, maybe boldface, I don't know, but it doesn't look right in that font. This is a variable width font, and really it would if you had written it in a typewriter style, it would have come out looking like the name of a file to me. Okay, so. Now, so this is a case where using the typewriter style of type, which is there, would be a better, better convention for referring to something that's a name of a file, which is something that is a definite typewriter-y thing. Now, again, this is a freshman here who's writing his first short program in web. And I'm expecting to find lots of things, of course, because I told him to just do something and let me criticize it. I didn't tell him to spend much time polishing or anything. Don't get the wrong idea here. The modules here, one was called variables, one was called type, and I said make them both plural if you're going to do that. Now. Oh goodness, what was I going to say here? There's a bunch of things, but I don't want to get into unnecessary stuff. Here was a case again where a long piece of code could be broken very nicely into two modules. So when I put this line around this business here, this said this would now become another module called read the next line of input into data of counter and append a % sign, and then that would be then that module would do it. It would read the next line into it, and then there would be a corresponding one, write data as a new line of output. And then I suggested there would be a parallel way to make an elegant code or something to look for anyway. Well, so that was simply a case of taking a large piece of code, then finding a small part that could be understood as a unit, and unifying it. This person has a convention that when he writes, when he gets to an end, he says in a comment saying what kind of thing is ended: end of a while, end of a while, end of a for statement, end of a while, and so on. Those comments are no longer necessary when you have the web system, I think, because the indentation makes it clear what's ending at this point. So there are places where where you've used in your other form of programming, conventions were developed which were appropriate to that style because they got around some of the problems of that style of programming. But then those solutions are they're just excess baggage when you bring over to another style often. Okay. Here's another kind of something that I should mention sometime in this course, and that is when you're communicating with a user, this is another kind of mathematical writing or technical writing. All your messages that go out on the terminal and back in, that's language and so on. Think about style of communicating. And so here this is name a file to reverse, please, and so on. And then that's a prompt, and it's reasonable. And I was just saying, what if you said, what file shall I reverse? Something like that, or should I reverse? And that's another way to prompt a user that I wanted to discuss a little bit, using first person. The computer is talking as if it's an animate object and says I, some people think this is very almost immoral to have computers personified. I think Dijkstra is very against any kind of anthropomorphic language with respect to computers. But I think it's very effective, and I always think of it when I'm talking about protocols or something. It's much easier to think about handshaking, and this guy says something to that guy instead of saying this process says something to that process. It doesn't make any sense. It's much more easy for me to conceptualize Alice and Bill making an exchange than two abstract processes. And so anyway, I go for using first person in communication with users as a recommendation that I think works nice. Some people might be offended, though. Of course, the ELIZA program and these things did this and fooled everybody. They would say, this. You know what I mean? The program that the doctor is in now, and it says, please state your problem, and then it says, I understand, and and all this, and what?
How long have you felt this way?
Yes, right, that's right, and it quotes this X from your previous sentence and everything, and so it makes it seem as though there's more going on here. You can certainly pull magic tricks this way, but you can also do this more effectively than sticking to only abstract stuff. Okay, now here's a case of starting a sentence with a symbol. Data is the name of a variable here, and so it says data assumes that no novel file will be more than 5,000 lines long, which to me appears far more than enough. So I just added a few words. The big data array assumes that no, and so on. Because in Pascal, you have to declare the size of your arrays. So again, it seemed to me jarring to start out the sentence with a lowercase letter and starting out with a symbol. Now the second program this freshman wrote was very pleasant for me to read. Because he has a unique style which very well came through in his writing, and you'll see that as in the next minute or two. he starts out and he says, let's see what we need to put in the main body and all this. He's giving you the stream of consciousness, all right. Now, one thing that was clearly could be improved in this starting point was he had module 1, the main body, and then that was it. There's nothing there, and so you should start out and say something. I mean, what? So you say this program does what, and so you want to have some kind of introduction, and then I would put that as the Pascal text to module 1, which has nothing. So there should be something there, and then these other things, these definitions, which define conventions that are used elsewhere. For example, counts is a synonym for, it's a macro, it's a synonym for count 1, count 2, but it's not motivated at the moment. But he gives a comment that says the following are defined for ease of reading and writing the program. That's the motivation, but that comes after. The program comes first, and then, so this part of the thing should belong in module 1, and then these definitions nice in module 2. Here I suggested a better name for this. He called it range, but range is not very descriptive. That could mean anything, so why not call it caps or caps range, because he's defining a range of capital letters and things like that. Okay. Now, he is implementing a rather complicated procedure here, and I'm not going to go into that, but but he has things called the brain. He says, well, let's try and see if we can read in the data and set up a graph. Okay. Let's see, where are we going to do it? Now that we have the meat of the program down, let's get to the nitty-gritty. His personality was certainly coming through in the style. It says, aha, 2 more variables. Well, you would have to go all the way back to the var section in ordinary Pascal. All we do in web is add them right here. It says, how about a web programming contest in which you are unable to back up in the program? Okay, so, and here I just commented that's the best exposition of a program, except for people who especially for people who never get better ideas and throw stuff away. But anyway, he was realizing at this point that he could declare a variable right here where he wanted to, and he didn't have to go back and put it in. And he says, well, this is great, but we have to initialize hash table to some sort of initial value. Since I have more cells than the number of characters in most reasonable books, I will mark those and so on. So, but he got the feeling of enthusiasm into this better than anybody else I've seen in a program. His program is called Components, but the name of the program here is Complements, and I wondered why he called it Complements, and finally I found out that they're both the same for him. Complement and component are the same, and so I told him that I had to warn him that those words are slightly different. Okay. Now, the asterisks here got up high. If he had used a typewriter style asterisk, it would have been down lower and looked more like an asterisk that you would see in a text file. That's just a minor point, but I think when you're communicating about computer programs, it's worth noting that asterisk is in a computer terminal tends to be down low, centered, like the letter C or something like that. But if it's an asterisk that's in a standard font of type that you get from a typesetter, as opposed to a computer terminal asterisk, it tends to be way up high. And if you've only got one in a font, then it tends to be problems. That is, you find when you start computer science writing that you're marking all the asterisks to be lowered to the printer if they don't already have a body-centered asterisk. Here's a cute thing I had never seen in Exposition before, and I'm not recommending it, but I just thought it was cute. It says, it goes down a list of characters that we have used, and it says, "Pren, remember a double star, question mark, why?" So in other words, he's got this prompt, and he always also answers it with a why here, so he's talking computerese very self-consciously, but it was still kind of cute. Okay. We've just introduced several more variables. Better declare them. All are pretty trivial. I trust the general reader to understand their use. This is not a good thing to trust the general reader to. I mean, I have a general rule that whenever you declare a variable, always give a comment about what the significance of that variable is, even if the name of the variable is rather self-descriptive. This is the best place for a comment that's sort of an informal invariant about what that variable satisfies. Sometimes the variable is really just so trivial that it doesn't deserve a comment, and then you just say, you know, temporary variable for manipulation or something, but I would still say that in a comment. But if it's a count, you would say, you know, this is how many names there are or something, not just a counter, but you would say, you know, something that describes what the variable means. Always give a comment whenever you define a variable, I'd say. All right. Now, another freshman, first use of web, has a program that was processing the Mona Lisa in an interesting way, and this program reads a data file, a digitized version of the famous Mona Lisa painting, which is considered to be a single undirected graph. And he explains in which way. I mean, it has rows and columns, and that's an instance matrix, and you make a graph out of it. Well, now here is an asterisk used for multiplication. It doesn't work very well. I mean, a high asterisk up there for multiplication. Anyway, even if it were down low, it'd be better replace it by a multiplication sign, I think. And then you would say rows here, of course, because you're saying columns in order to be consistent. Here, using the style here, he decided that the title of every module would be used with all caps. I mean, capitalize every word after the first one. Now that's something that's difficult to do automatically. You capitalize the word "and" too. Usually, if we're capitalizing something and mixing caps and lowercase, we in a title we would take the most common words like "of" and things like that, and not capitalize them. And when you get newspaper headlines and things like that, except I guess they have a rule that if you start a new line, you break the headline into two lines, and the second line starts with "and," you still capitalize the "and" sometimes. A lot of people, I don't know. But it didn't work too well in web programs, so I suggest not doing that. Just capitalize the first one, which seemed to work well to have it. I experimented with both ways, and capitalizing the first one seemed to work. Not putting a period at the end seemed to be good, but not capitalizing the whole word seemed to work. Here's another point about this goes into ordinary technical writing. Here's talking about bytes. Now, and hexadecimal notation. Now, here's another place where fonts can help in exposition. If you're writing hexadecimal, typewriter type turns out to be a nice code for saying this is a hexadecimal number. So if you see a use of typewriter type for a number, you might know that that's base 16 automatically. But now he had it right at the beginning, but then he should have put the 63 in Roman. So here he has the 3F. This is in typewriter style. And he says 3F represents 63. That 63 should be ordinary Roman in decimal. So the normal decimal type, normal decimal numbers in normal type. But when you say double F represents white, double 0 represents black, those are in typewriter, indicating these are hexadecimal digits. Okay, worthwhile typewriter type seems to have a nice machine-oriented function to it that helps distinguish itself here. Now, here's a matter of exposition. This is a fairly good-sized program. It's about 57 modules, and it's trying to look at the essentially it has 90,000 pixels of Mona Lisa, and it's trying to pick out the darkest ones, I think, in the whole array. And so it's using a heap for this, the kind of heap that means used for a priority queue, so that you can find the 1,000 largest elements in the heap. You don't store all the pixels in memory, but you only store the currently largest ones in this kind of data structure called a heap. And so he has this, at this point in his program, he's mentioned that he's going to use a heap for his data structure. And now he's defined it, and we got the data structure for it. But then then the program goes on and talks about a complicated graph theory algorithm, and then finally, when we get to module 52 or something, we go and do a sort on the heap. This is, but the reader of the program is all geared up and understands heaps right now, so it would work out better to get through while this is fresh in mind, to do that part of the program that's going to use the heap at this point. And you can do that with web. You can put code in at any point. You don't have to write top down or bottom up or any other order. You can write in whatever order you think is right for exposition, and the web system is going to put the program together into the order that the machine needs it later on. So at this point, it would be a good idea to give the algorithm for heap sort. Now, however, you get a problem. That is, the sort routine calls one of the in his program. His sort routine has a call on another procedure called add edge, which isn't declared yet. Which is going to be part of his graph theory algorithm, and we're not ready to understand that at all yet. We have to push that down. So how do you do that? Well, in web you can insert, like in here under procedures and you can insert the sorting procedure as a separate module and then that'll get put in before the other procedures. You can call it the sorting procedure and call that here instead of procedures and functions used and add it to that part of the program. You just call it the sorting procedure, and then you'll be guaranteed that the sorting procedure will come last after the other procedures that it actually calls. And when we get to that part of the procedure, it would be easy here's the sorting procedure, and it would be easy to take this part of it and replace it by something called use the largest element of the heap to add an edge to the graph. Then this module would have some number to it, like it would have a number 50, which would show the reader this is coming up later after we understand what it means to add an edge to the graph. And we could then understand this much of it perfectly well while we know what a heap is and about sorting, and we wouldn't have to mix all the things together in our minds and we could get the heap stuff out of the way once and for all. Okay. One of the problems about documentation is that it should actually match the formal thing. So here he has a variable called avail, but in his documentation he calls it a, and that can be confusing. I mean, if you don't, so you got to make sure there's nobody checking that this informal description actually matches the formal one. Okay, now let's see. Anything else here? Not too important there. Okay, nothing terribly important here. These two modules are really the same, so there's no reason to have two separate modules for that. But I had a more important thing. Oh yeah, here. As a matter of style in web, I found that it was generally better when I have the name of a module like join isolated vertices. It would be good to start that code with the word begin and end the code with the word end. Instead of saying begin and then join isolated vertices and then end around, instead of putting the begin and end around the call of that code, put that code, put it inside the code, because syntactically it looks like join isolated vertices is a unit. And if you didn't have a begin and end there and you just wrote it in here, it would look like, because these brackets here look like parentheses, it looks like it's got a begin and end around it. You'd have a terrible bug, because Pascal would only associate the first statement here with the if then, and you would read through this, it would look like it's saying something other than it really does. So make a general convention on myself that I put a begin and end inside the modules. Now, of course, if I had a programming system, if web were not being patched on top of Pascal, and I was really using a programming environment, my programming environment would do this for me. It would make sure that I wouldn't make such errors. I have to use that discipline, but it certainly makes a better looking exposition to put the begin and end inside than outside. Oh, I'm sorry. I went way over time. I'm very sorry today. So see you Friday. So.